Welcome back to Josh Does Math. In this video, we're going to be looking at the discontinuity of the function root of x squared. So you might be tempted to just write this as, oh, I'm taking the root of x squared, so I'm just going to write that as x. But you would be wrong if you do that because you're changing the function that you're given. So you don't want to simplify and mess with and cancel things out. You don't want to do that. We're just looking at the function that we're given, and we're trying to find the points of discontinuity for this function without simplifying it and changing the function. So when is a function discontinuous? Well, we know it's continuous if the function gives us a value for every x, if the limit exists at every x, and if the function value is equal to the limit value for every x. Well, the easiest condition that we can check first is going to be making sure that the function is defined for every x. And when would this function not be defined for x? Well, if whatever's under the root, if that is negative or less than 0. Okay, so let's solve this right here. And this will tell us when the function does not give us a value. And those are going to end up being the only points where this is discontinuous. So let's see when this function doesn't give us a value. I'm going to take the root of each side. So I get absolute value of x is less than 0. In other words, I can rewrite this if the magnitude of x is less than 0. I know that x itself has to be less than 0 and has to be greater than 0. I just kind of mirror this side. That's how you deal with absolute values being less than or greater than some number. You get it sandwiched between the positive of this number and the negative of that number, which since it's 0, it's all the same thing. 0 is less than x, which is less than 0. Okay, so tell me what values of x satisfy this. Well, none actually. So find the points of discontinuity of the function. No x values. No x values are going to give us a discontinuity. This function is continuous for everything. Because if you think about it, we have x squared, so that's going to be a parabola. And we're taking the square root of all of these x's. So we know the square root only returns the positive value. So we should get the identity function, but instead, since the square root only gives us positives, if you just look at the positives here, we're definitely going to get this, since we're undoing the squaring with the root. And for the negative numbers here, if we take the root of those, we're also going to get a positive number, so it's going to look like the absolute value function. And that is continuous for all values of x. So where is it discontinuous? Well, no values. So thanks for watching.